very much. Good evening, everyone. The bar's open, right? Excellent. So I'm not actually between you and beer, which is handy, because I was a bit worried. There's some people down here going, cheers, fantastic. So Ian Cooper, who's sitting down in the front row here, apparently did a very, very good job earlier, but not everyone could get in the room. So I thought what I'd do is do his talk again this evening, so you all get to see it. It's not strictly true. So first of all, I'd like to thank the organizers of GOTO for inviting me here. This conference is really dear to my heart. I think it was the first ever sort of non-trade conference I went to back when it was called Yahoo, Java and Object Oriented, in Aarhus, back in 2008, I think it was. And I had my tiny little mind blown wide open, right? Because suddenly there's just all these amazing people around to hang out with, to talk to, attendees, speakers. I don't know if people remember back in those days when it was in Aarhus. Then I apologise for my Danish pronunciation, by the way. But there's a pub just down the road from the venue called the Sherlock Holmes. Anyone know or remember the Sherlock Holmes? Yeah, we got some people. With the creepy back smoking room, with the creepy mannequins in there. Very strange. And I remember being there, like in my early 30s. My first ever conference, and there was this, I say conversation, it wasn't, it was a stand-up row between Bedara Dave Thomas, OTI Dave Thomas, and Brian Getz about the future of Java, the programming language. So this is the guy who is behind Eclipse on one hand, and IBM's open source strategy, and the Java architect, having a screaming row with one another in the bar. And I thought, I was terrified for a start with my beer, but I thought this is fantastic. This is a place where you can come and have these conversations and meet these people. And I hope coming here for these few days, you find the same thing that I did, because I still love coming back. I still love being invited. And many years on, I'm standing on stage in front of you doing an evening keynote. So there's hope for everyone, because I never thought that would happen. But I guess I'm not really here to reminisce about the old days of GOTO. I'm here to talk about, or do another form of reminiscence about the old days of microservices. So what I'm planning on doing is talking a little bit about some of the forces that were at large at the time, that a bunch of us got together and came up with these ideas. So some of the forces that sort of led us down that path, and then some of the people that were inspiring at the time and whose thoughts led to these ideas. And then I'll talk through the ideas themselves, the characteristics of microservices. I'm not going to go into tremendous detail about everyone, because that would take for the rest of, I guess, the conference, because there's a lot of things in there. One of the things I think about microservices is first of all, the name is terrible, so sorry about that. Right. Now, we heard from Kent Beck lunchtime, and Kent was talking about extreme programming. And when I think about extreme programming, I think about the diagram of all the interlocking parts of extreme programming, the different practices, and the idea that we do all of these things all at once and turn it up to 11. That always stuck in my mind from reading about XP in the olden days. And I think a lot about microservices like that. It's about doing a bunch of modern software engineering stuff, all the practices that we know kind of work, and doing them all the time and turning them up to 11. And that's kind of where these ideas came from. So without further ado, I'm going to talk a little bit about the stuff that was on my mind, and I guess for the older folk in the room, our minds back sort of 12, 14 or so years ago. So stuff was big, right? Big monoliths. And I'm not talking the sort of monoliths, we talk about Spring and modular monoliths, and should we go back to building monoliths? This wasn't the sort of monoliths we were seeing 15 years ago. We were seeing 5, 10, 20 million lines of code monoliths, right? That's what we meant by monolith back then. Not, should we make a slightly bigger service and pretend it's a monolith? I was at a bank recently in a European country that I won't name. They had a monolith there. It was 250 million lines of COBOL code, right? These things still exist. These are the forces that were in play at the time, these huge, giant pieces of software that were really hard to change and often tied together by really sort of intricate database-to-database calls or SOAP messaging, or SOAP RPC, and then document-oriented SOAP and so on. So big, difficult things to change. A lot of the tooling that was around, a lot of these sort of, the stuff we were using to build software was big and enterprise-y. And I can start saying that, I find it hard to stop saying it, enterprise-y. Big stuff, right? So things like JBoss, ClearCase, WebFear, big Oracle Forms and PL SQL stuff, Mercury testing suites. Fun fact, Selenium, the precursor to WebDriver, which is now the W3C standard for, I guess, web acceptance testing. Selenium was called Selenium because it's the antidote to mercury poisoning. I don't know if you knew that. That's a true story. You know, we had IIS, big I, and the interesting thing about a lot of this tooling is that, you know, it was a lot of these sort of application servers and so on, is you would build a thing, DLL, you build a WAR file or whatever, or an EAR if you're unlucky, and then you would install it into one of these application servers, which took a long time to start. They were quite hard to work with. And you install it into this application container. It's not like that we do that now, is it? We don't build software, put it into a package, and install it into something to run it for us. Kubernetes, anyone? I don't know, just in case that's going over your head. But anyway, back in the day, this is what we had: big, heavyweight tools. Integration was. I mean, this is the WS Death Star, as it was known, set of standards. There is an ontological standard in this for managing the ontologies of the integration frameworks that made up WS Death Star. You need an ontology to manage the integration. It was big, it was heavy, and it was hard. Lots of stuff were controversial or new. So, you know, things like Spring, XP, trunk-based development, cloud, AWS, things like even Tomcat was sometimes controversial because surely WebFear is enough for everyone and we've paid for that license. Right? JUnit, you know, testing in advance of writing code. What crazy person thought of that? Lots of this stuff was controversial and or new at the time. And obviously, the idea that you would actually have a domain model in your code was crazy. Right? Strings and integers were enough for everyone. Right? So actually having classes named after the thing that you were modeling, why would you do that? What possible use could that have? This was the world back then. This is the world in sort of 2009, 2008, 2010. I mean, there were some good points to this. Developers and ops, they were the best of friends, right? So that was fine. No misaligned incentives back then. No people, you know, optimized for, you know, stability and people optimized for change on the other side. No. Oh, wait. I'll just leave that there. So there's this sort of interesting moment in time where we've got all these quite heavy tools, big enterprises with big bits of software, these big monolithic applications, but also sets of new practices emerging, domain-driven design, these sorts of things, test-driven development, extreme programming, that a group of people that I was fortunate to work with seized on, essentially. It was time to cross the Rubicon. Now, this is my version of where microservices came from for me, right? So your mileage may vary. There are other people in this room who've been on the same journey, actually. But this is kind of my origin story. So there was this explosion of interesting ideas and people. Some of these people are at the conference. So Daniel Tilhorst North, he was talking about replaceable component architectures back then. There's a guy called, Chris Reed. There's people on here you probably never heard of, but have been very influential. Chris Reed sort of co-created the idea of DevOps, was one of the people originally behind DevOps Days. Sam Newman, who went on to write Building Microservices. And this is a guy called Joe Warnes down here, who's, to quote Dan's talk tomorrow, the best programmer that Dan knows. But there were these other things happening, right? Continuous delivery. Dave Farley, Jez Humble had put this together. You know, we had things like enterprise integration patterns. Gregor was trying to understand how we could better integrate using messaging software. We had REST in practice, talking about how we can use the web to do integration rather than these really, really heavyweight standards. Domain-driven design, and then finally release it, which, again, what was one of those books that blew my tiny little mind. All the patterns that we think about now in terms of reliability and stability, most of these patterns and in deployment and so on, are represented up here in some of these books. Things like bulkheading, things like circuit breaking. All these ideas come from these people, books, and various others. Big shout out to Russ in the front row and his work on anti-fragility, which was happening around the same time. How do you build systems that are anti-fragile? So there's this explosion of interesting people that I was hanging around with, working with, books that I was reading, lucky enough to do so. Then I was very lucky. I was invited to a workshop called the Software Architecture Workshop, a European sort of symposium, if you like. And I went to this place, Castel Brando, the Pope's former holiday home. Why wouldn't you have a workshop there? That's what it looks like. It's even got a funicular. This is back in 2011. And there was a whole bunch of interesting people there having interesting conversations. So you might recognize some people here if you're in the world of messaging and services and things. This is Udi Dahan, he was there, and Service Bus Udi. And this is Gregor, he's there as well. And there were others, Jimmy Nielsen from the domain-driven design community. A lot of people, Stefan Tilkov, who's obviously very big in the REST and service-oriented architecture world. And they were all in this place. And over the course of 3 days, as it was an unconference, unconferences, they tend towards a theme over the course of the 3 days. And on the last day, the theme was quite clear. Why do we have to spend so much time maintaining all these big things? Right, how do we make changes in parallel? How do we, as Kent was talking about earlier, avoid stopping the flow of features so that we can tackle technical debt when we've got all these big products and big services and things? And from that came this sort of realization, I think, over the course of these, on the third day, maybe we're solving the wrong problem. Maybe the problem is the size. And maybe if we built lots of smaller things instead, maybe that might help. And so, that was back in 2011 at Castel Brando. We were talking about micro-applications then. That was a slightly different name amongst this group of people, this group of originators of these ideas. And then this guy turned up at a project I was working on. Would you buy a used car from this man? I do have a T-shirt. I actually have it in the hotel. You might have seen it before if you've seen me speak. It says, Turing's dead, Martin Fowler said no, Sam Newman couldn't make it, hi, I'm James Lewis. Right? But the problem is that Martin Fowler is here, so I thought it would be silly to wear it, really. So Martin does his Martin thing, which is bumblebee around inside Thoughtworks, going to different countries, visiting interesting projects, right, understanding what people are doing, what exciting new innovations are happening. Because, you can go and try and create and be innovative, right? Let's be innovative. But actually, my experience, and I think the experience of my colleagues, is that innovation happens ground up. It happens by people solving hard problems, working, in our case, as consultants for our clients. All those examples, continuous delivery, that's an example of that. Things like behavior-driven development, examples of that. Selenium, and now WebDriver, examples of that. And Martin's great talent is visiting people and harvesting these ideas and then encouraging people to talk about it. And so he visited the project I was working on, and we talked about these ideas that we were putting into practice because we had a particular set of requirements. And then a little bit later, I talked about it for the first time publicly. QCon San Francisco 2012. And I did this talk called Microservices - we lost the hyphen, Java the Unix way. Because at the time, I was thinking about these things as these little processes that shared like a uniform interface. In our case, we were using HTTP, and we were using sort of well-defined standards like Atom and Atom Pub to sort of build this big, complex loyalty management platform, as it happened. This was the subtitle, What I Did Last Summer, or How We Designed and Built a Resource-Oriented, Event-Driven System out of applications about 1,000 lines long. So I did this talk. I also did a workshop, which actually turned into the set of workshops that Sam Newman and I started doing, and then Sam turned it into a book. So if you wonder where building microservices comes from, it's from those workshops. And I did this workshop where I talked through these ideas that I'll come to in a moment. And I had some very interesting people in the workshop. I had the guy who sat next to Roy Fielding at Adobe, I think he was at the time, the guy behind, obviously, the RESTful architecture. That was his PhD paper. He came up to me at lunchtime and said, I like the way you described a hypermedia as the engine of application state, and I sit next to Roy Fielding. And I thought, well, that's lucky. It could have been really awkward. But everyone in the room, more or less, were confused, and people were confused at the talk. What are you talking about? Why are you talking about building these small things like this? And then that turned into, eventually, some years later, because as Martin knows, writing for me is like getting blood out of a stone, turned into the microservices article on Martin's site. But some of the things we were talking about in that talk, I talked about in that talk, I thought it might be interesting to see. So these are the things I was calling out. Small with a single responsibility. Each application only does one thing. Small enough to fit in your head. You can understand everything it does in its entirety. In the same way that good classes, object-oriented design means that you can understand everything about an object or about a method. It does one thing alone. Small enough that you can throw them away and rewrite them. This is an interesting one, located in different version control routes. Each of the little applications completely separate from one another. And any shared code should only be library code or infrastructure code, no shared domain code. And the reason we put these in different routes, if we're using Git, different Git repos, was because I'm stupid. Generally, that's the reason, because I know that I am incapable of when I see an abstraction in two places. Oh, there's a customer and a customer. Oh, they look the same. I'll put them together. Brilliant. Now we've got a huge customer, right? That happens all the time, or used to happen all the time, and I'm incapable of doing that, of not doing that rather. But if you put them in separate Git repos, then at least you've got the overhead of having to manage different Git repos and having to, now what do I do? Create a new library for customers and include them? But we don't do shared domain code. So that was the reason originally behind this idea of microservices not sharing repositories. Containerless and installed as well-behaved Unix services. Now, this was revolutionary at the time. Remember, this was the age of Tomcat, JBoss, IIS, where you would build a thing and install it into a thing for it to run it. Instead, we were using really, really simple technology, things like Jetty, where you could just compile a big jar and Java-jar run it, and install them as Unix daemons, essentially. Run them like that. Again, different to how we were used to building and deploying software at the time, and then provisioned automatically. Right, none of this stuff works unless you're able to deploy these things automatically through a build pipeline, getting fast feedback from tests failing at different stages along the way. And at the end, I described this consistent and reinforcing set of practices, hexagonal business capabilities. Now, I'm going to call this out initially, right? The hexagonal thing for me was because hexagons tessellate. So it felt like a nice thing to describe these things as tessellating. They kind of fitted together nicely. Of course, it turns out that hexagonal architecture had a very different meaning that I didn't realize at the time. So they should probably be called something else. But hexagonal business capabilities composed of these microservices that you can rewrite rather than maintain, which form this sort of distributed bounded context, deployed as containerless OS services, etc., etc., etc. I should point out, as I said, that's my journey towards this. There were a bunch of other people going on the same journey at the time. And this is just the people I know about. I'm sure many of you in the room, when faced with the same forces, were thinking the same things. But just to call out Stefan Tilkoff, unfortunately he passed away last year. He's a big loss to us. He's a big friend of this conference, Stefan. He came up with this idea of self-contained systems. Daniel Tilhorst North was talking about replaceable component architectures. Adrian Cockcroft at Netflix, fine-grained service-oriented architectures. And then Fred George, in his somewhat, let's say entertaining take on how to build teams in programmer anarchy, was also talking about what were really sort of nano services, if you like. So very, very small things. And then a little bit later, after, literally this is true, the only way Martin Fowler could persuade me to write this, or get me to write this, was by basically inviting me for a sleepover. It's a true story. So I went for a week-long sleepover at Martin and Cindy's house in Boston, and we thrashed out the first draft of this article, which we published March 2014. And in this, we called out these characteristics based on what I've talked to you about, based on the learnings we've had since. And I'm going to sort of go through some of those now. So this is the set of things we called out. Now, the first thing is this idea of componentization via services. What do we mean when we said that? So, to start with, we wanted to define our terms. When talking about components, we run into the difficult definition of what is a component. Our definition is that a component is a unit of software that is independently replaceable and upgradable. You can do this in monolithic applications, obviously, modular monoliths, but with services, it's somewhat easier. We then went on to say one main reason for using services as components rather than libraries is that services are independently deployable. I'm not sure if Ian was talking much about independent deployability today. It'll feature a bit later in this as well, because I think this is one of the things we're still not really good at, is independently deploying these things. And many of the problems I see organizations get into because their services aren't independently deployable. They have to be deployed together, tested together, integrated before being deployed as one thing. But at the time, we were saying these are independently deployable things. The next thing that I was really keen on sort of getting in there was this idea of late binding. Kent Beck was talking about coupling. What does coupling mean? If I change the API in this thing, do I have to change the API in this other thing? For me, it comes back to this original definition, or one definition of object-oriented programming from Alan Kay. To me, it means only messaging, local retention and protection, hiding of state processes, and extreme late binding of all the things. Now, again, if you remember where we were sort of coming from, this is very much the kind of WS star world. We were doing SOAP, RPC, or if you were lucky, document-oriented SOAP. Where it was common for you to basically get a schema, you build your client-side libraries, you include those in your jar file, you program against those, and then you deploy that. If anything changes upstream, downstream, wherever it is, what do you do? Well, your service falls over, for a start, because you can no longer create the objects you need in your code. So what you have to do is go back to the start, and you have to say, okay, we'll get the schema again, we'll recompile, build the libraries, we'll recompile my thing, and we'll deploy it. So for me, extreme late binding of all the things was super important, right? Using things like RESTful protocols between these small things so that they could talk to one another allowed you to decouple them from changes to one another, essentially. That was the key thing, or one key thing for me. It's also one of the reasons that we talked about different version control routes. Because by putting things in different version control routes, you're kind of enforcing some of this late binding. You're enforcing the idea we don't want to use build client libraries to talk to other services. We'll do things like use XPath or other things instead. The next thing is that was driving this a lot. There was a huge, it's still the case today. I don't know why. Programmers are obsessed with threading, right? They're obsessed with multi-threaded code, building multi-threaded applications. And Daniel Tilhorst North and myself back in Thoughtworks in 2000 and something, we did this talk on the strong foundations track of our internal conference, where we had Dan and James's law of concurrency, right? Doug Lee knows more about it than you do. Now, Doug Lee was the guy behind JSR 311, which started introducing more of the kind of the things like in-memory queues, that kind of stuff into the Java programming language at the time, in the Java language at the time. Our point when we were saying here is, yeah, just use the stuff that other people do who know about it more than you. But even better than that, maybe don't use threads at all. Right? Maybe scale via process. And this is when the 12-factor app, sort of manifesto or whatever it's called, started to appear. And in the 12-factor app, one of these things is related to concurrency. Don't scale via threads, scale via processes. So suddenly we had this idea of componentization via services that are extremely late binded to one another via whatever domain application protocol you were using, REST most of the time at the time, and you were scaling these things out via processes. Now, I should, old man shouting at clouds here. I still can't tell you how big they are, which is unfortunate. How big are these things? Don't know, shrug. They're the right size for the problem you're trying to solve. They're bigger if you've got transaction boundaries that you don't want to do distributed transactions in, or for other like financial reasons, maybe they're mission critical. I think Ian was talking about that earlier. But I still can't answer that question. The key thing is that you should be able to understand them in their entirety. They should fit in your head. The next thing is this nouns versus verbs, and I think we've got. This is really me shouting at clouds. I lost this battle. Michael Nygaard, I think, is in the audience probably somewhere. He's certainly at the conference. He wrote a brilliant blog some years ago now about how we're building these services all wrong, and that entity services based on nouns basically introduce all sorts of difficult effects around coupling between and basically having to build these big call graphs when you need to get a single thing done. So entity service is bad, verb service is good. I'm going to leave it there. You can go and look it up for yourselves. So the next thing is this organized around business capabilities. You could do an entire conference on this. There are entire conferences on this. So I'm just going to tell a couple of funny stories instead. This is Melvin Conway. Conway's law is a thing. And that's why we should organize around business capabilities, essentially. Business capabilities, they're the stable bits of our businesses, right? When you look at probably how the business is structured as opposed to IT, you're seeing business capabilities. You're seeing things like, warehousing. You're seeing things like, manufacturing. You're seeing things like, okay, there's various forms of sale channels and things like that as well. Those are the business capabilities that we were talking about. These big things. And the key thing about those is that they're stable because they're what the business does as opposed to how the business does it. How the business changes over time. If you're an actuary in an insurer, right, or a reinsurer, or wherever, like a while ago, you were using lots of tables and calculators, right, to do your job. These days, you don't have you do have lots of tables and calculators, but they're in the computer helping you with your job. But you still have to have actuarial services, right? And that's why we said business capabilities. And if you organize like this, you organize your teams around these things, then the software you build forms these stable elements around it. Sorry, I've just looked down here, and the clock's updated, which is good. I no longer have 55 minutes left because you were going to be here all night. Organized around business capabilities. I did this talk called How I Finally Stopped Worrying and Learned to Love Conway's Law, and a bit later on I got this lovely email. Hi James, I've recently come upon your presentations, blah, blah, blah. No, I'm not sitting on the balcony laughing at you. I'm sitting at my computer learning from you, and your depiction of me as a Muppets figure keeps me humble. Keep up the good work. All the best, Mel. I was actually lucky enough at an event, I think I was with Michael Nygaard at the time, to meet Mel Conway. He's a real person. He actually exists in email and in real life. And his wife, Elizabeth, was there. And she came over and she went, Are you James Lewis? I was like, yeah. And she said, I want to say thank you, because those presentations where you depicted Mel as a Muppet made all of our grandkids like just destroy themselves laughing. So that was a nice moment that I could make Mel's grandkids happy. The next thing I'm going to talk about, I'll go into a little bit more detail about this, but decentralized data management. In this, we talked about how decentralized data management can often lead to distributed transactions, which are notoriously difficult to implement. I mean, this is like a truism. I'm not telling you anything you don't know. And then once we'd sort of decided that we were going to split these things up, suddenly everyone, like from nowhere, everyone had to become an expert on CAP theorem. So I'm really sorry about that. That wasn't my intention. I mean, it's cool to talk about CAP theorem, right? It's cool to talk about how you can only have two out of the three properties of consistency, availability, and partitioning. But suddenly, everyone had to learn about all this stuff. It's like, oh my God. And there's a whole bunch of stuff around, how can you beat the CAP theorem? There's a checklist here. Which proves you can't beat the CAP theorem, even if you think you can. Michael Nigel did a brilliant talk about exploiting loopholes in CAP theory some time ago. Go and have a look at that. I presume it's still online. And then I saw a brilliant original. It was when Google were talking about Cloud Spanner, about Spanner, at GOTO Berlin many years ago now. And they were talking about true time. They're like, yeah, we've solved for CAP theorem, right? Because we've solved for globally distributed consistency and availability using in Spanner because we bought up all the atomic clocks. Literally, they were kind of like, yeah, we've just built this system that's based on GPS and atomic clocks. And you can't buy any now because we got them all. We have to make more. And then they said, oh, by the way, we're not cheating CAP theorem. It's just our networks are so reliable, we never partition. And I thought, well, that's good for Google, Great, what about the rest of us? How do we solve for that? Anyway, we had to become an expert in CAP theorem. So this is shouting at the moon, shouting at the clouds thing. Favor bigger service boundaries over distributed transactions. That's probably the key takeaway from this. If you've ever faced with the idea of having to do a distributed transaction, don't favor bigger services. Now, the next thing is this idea of products, not projects. And this, I'm not sure if this was the first time this term was coined. It might well have been. But in this, we were talking about how we're going to build these sort of long-lived autonomous teams that we're going to use this build it, run it model based off the ideas coming out from Amazon and then from AWS and so on. Let's build it, run it. So the teams they've got everything they need to do their job within the team, all the skills, all the roles, and they're going to not only build the software, but they're not going to throw it over the fence. They're going to run it themselves. And I've been living this. I've been doing this for a couple of years by this point on various client projects. And the effect it has when you add that constraint in, I took a lot more care over the code I was committing than the tests I was writing, certainly. And I certainly took a lot more care over observability characteristics and so on. But the key thing here is that a team should own its product over its full lifetime, as opposed to the common thing at the time, which was project-based funding. Right? It's a funding model more than anything else. This funding model change, an organizational change. So rather than get some money to do a thing, and then the thing stops, and you get some money to do a different thing, and the people go over there and do the different thing. You don't do that. You get this continuous funding for a product over its lifetime. So one of my colleagues, Siriam Narayan, he wrote this up brilliantly on Martin Fowler's site. He talks about products over projects. He talks about project mode is when a predefined solution or scope gets funded, where product mode is a team gets funded. Product mode team is funded on a rolling basis. It's kind of similar to business capabilities in a sense. They're the long-lived what of the business. Product teams are the long-lived financial constructs that enable fast flow and the how to do stuff of the business. There's another quote from Siriam. The key thing with this is it enables economies of flow. Right? The ability to optimize over time, optimize the way your team is building software to enable economies of flow. And if you enable economies of flow, you make more money or other stuff. There's been a ton of work that's come out. Oh, let me go back, sorry. a ton of work has sort of been done over the years on the ideas of product teams. I'm not going to go into all that. But I do have to recommend team topologies because it's amazing. But also dynamic reteaming by Heidi Helford. This is a fantastic look at how you can solve for some of the problems you see with product-based teams, which is, we haven't got enough work. Why are all these people sitting around and haven't got enough work? So how do you enable people to move around effectively, both for their own careers and also to enable fast flow? And I pulled up Netflix API with RxJava because this is a good example. The Netflix API team was a long-lived product team, famously rewrote their API about 3 or 4 times in different languages and different technologies because as they found out more about the problems they needed to solve, they were able to then go and solve those problems without having to get a new project funded. So the next thing I'll talk about briefly is centralized, decentralized governance. I say brief. You can't be brief about governance, really. It's funny because at the time, when we were talking in the article about this, we talked more about how this enabled you to make different technology choices. Hey, we can use Node and C++ if we want to. We're allowed to make that decision in our autonomous teams. You want to swap in a different database flavor, you can. Of course, everyone swaps databases all the time. That's really easy, right? JDBC lived up to its promise. If you want to use Node, that's fine. If you want to use C++ for something more complicated, you can do that as well. But I think, actually, one of the learnings for me is we kind of missed a trick here. We kind of missed the point. Because we didn't talk about the how of this. We didn't talk about how you actually enable autonomous teams to govern themselves, to self-govern, and to do decentralized governance in an organization. Because one of the ideas we had, or we're talking about, is this idea of town planning, right? So in towns, most towns aren't deliberately planned, right? To be honest. The town I live in is Stevenage in Hertfordshire. It was planned after the Second World War so that people could move from bombed-out London into Stevenage. There was a number of these towns ring around London. And the interesting thing here is they said, okay, what we're going to do is we're going to have specific areas, and then we're going to have these sort of common things between the areas. So we're going to have bike lanes between them. You should be able to get everything within your little area within 15 minutes, 15-minute city. I think there's the 5-minute city in one of the new developments in Copenhagen, actually, isn't there? And then you should have, each of these little units should have everything they need. They have doctors' surgeries, they have all the stuff, but they're connected by common sewage systems, road networks, electricity, all that stuff, right? And we sort of took that idea in terms of this idea of governance, right? So, how do you think about a system in the large and your organization in the large with these business capabilities that form this town plan? And then how do you think about how these things communicate? Well, we think about these shared utilities, these domain application protocols between these capabilities, between these parts of the town plan. And that's how we were sort of thinking about decentralized governance. Town planners care about the big. They don't care about what's in each of these little elements. That's for the teams to care about, right, in our world. But you put in place guardrails, you put in place constraints and principles that allow teams to do that, to work independently. This is hands up. First hands up. Come on. You're all falling asleep. Hands up. Who's read this? Yay! Awesome. Right. The rest of you need to go and read this. It's absolutely fantastic. It's one of the best books on leadership I've ever read. L. David Marquette. It's the story of how he took the worst performing submarine in the US Pacific Fleet and turned it into the best performing boat by every applicable metric. And he's got this lovely quote. I won't go into it too much, but this is key to decentralized governance. Don't move information to authority, move authority to the information. Make sure you've got enough structure, processes, controls, constraints, if you like, guardrails, evals, as it's called now in AI land, around to enable this to happen, to enable people to make decisions where they're doing the work. And that's how he turned the ship around. It's an amazing story. And if you don't think it can work for your organization on a nuclear submarine, it worked. So maybe take a look. The next thing here, there's been a ton of work done on this over the last number of years. My colleague, Andrew Hartman-Law, he's got a new book just about to come out, Facilitating Software Architecture. He talks about the human side of software architecture, how we can improve communication, some tools, things like building radars, using architecture decision records, and so on. Obviously, the software architect elevator talks a lot about this, how you travel between the different parts of your organization, from boardroom to engine room. Team topologies, again, is about governance in a lot of ways. And then building evolutionary architectures, how can we automate a lot of the governance stuff, the stuff that used to be hard? How can we write tests and run those tests as part of our builds so that some of the stuff around compliance, legal, all these things can be described as fitness functions and executed automatically. So a whole bunch of these, a whole bunch of work has been done on this since 2014. But the key thing is building autonomous teams, moving authority to them, and giving them the right information so that they can get the job done. Tip 10, this is from Java the Unix way. Make it easy to do the right thing and hard to do the wrong thing. Use tooling and architectural tests to make complex tasks simple. And I'll come on to some of the learnings from that a bit later. Now I'll come on to another way we can help with decentralizing governance, and this is obviously a big topic, platforms, platform engineering teams, and building platforms. In this, my former colleague Evan Botche, he talks about what he thinks about and what he talks about when he means platforms, trying to disambiguate the term. Gregor Hope has got this brilliant book out now, Platform Strategy. Recommend you take a look at it, because he goes into a lot of detail about different types of platforms and how to build them, how to think about them, and so on. Now, this became a big deal some years ago. I worked at Thoughtworks, and have I mentioned that? And we built this thing called the Tech Radar. And back in March 2017, we put platform engineering product teams in on Assess. A bit later on, it went into Adopt. We then, when we realized there was a bunch of people not kind of building the platform teams that we were sort of meant, and this is a kind of a side effect sometimes of trying to publicize these sorts of things, we said, okay, no, what we mean is you need product management applied to platform teams, like treat platforms as a real product. So you have product managers, technical product managers, and technical product owners helping you build the platform. Go out to the users, your developers, do user research, all that stuff. And a little bit later on, we went to March 22, put something on hold, which was really stop building platforms this really crappy way that you're all building platforms, right? Which is hey, we're going to build this thing, and then they'll all come and use my platform. It's never worked, it never will work. Right? Building these platforms as products incrementally, harvesting the good stuff that your teams are doing around the place, that's the way to evolve platforms, to evolve to a platform engineering team. Adrian Cockcroft, when he said at Netflix, his job, in a large part, was to go around and see the cool stuff that people were doing, his teams were doing, and to harvest that and turn it into kind of products. Right? A lot of the open source that came from Netflix are a result of those sort of ideas. And it's the same with platforms. Next thing, smart endpoints and dumb pipes. Back to this, right? And this is this huge WS Death Star specification. We wanted to try and move away from that. We were trying to move to this lighter weight way of communicating using things called domain application protocols, usually at the time using REST-ish protocols, and favoring sort of lightweight choreography as opposed to orchestration. I'm not sure if anyone in the room has actually seen this talk. It was done a long time ago now by Leonard Richardson. This turned into something called, or this is where he talked about the Richardson maturity model of RESTful integration practices. Again, there's a whole talk, well, there is a whole talk, it's that one, about this. But I wanted to call out a couple of things from this, because this is really how we were thinking about integration and decoupling at the time. He said the answer is not to automate away complexity, but to spread it around by splitting the complex thing into, I won't go into that, I'll summarize it instead. What he eventually said was, what we need to do when we're faced with a big thing is split it up, divide and conquer. URIs let us do that. Right? Use URIs to divide and conquer. We can reduce complexity by treating similar things the same way, right? So you can use HTTP, you can use the verbs, a get is a get is a get, a post is a post is a post. Turns out HTTP is a really smart protocol because really smart people were behind building it. And then the way you describe special behavior that enables you to integrate it allows the server to guide the evolution of the client's journey, if you like, is by using a hypermedia. Hypermedia is the engine of application state. The interesting thing is, and this is what happened in Java the Unix way, the story there, the product we were building, we took enterprise integration patterns and we took these ideas from REST, level 3 REST, and we smashed them together because someone had written a book about doing that called REST in Practice, which is about using really simple webby tools, web integration techniques, in order to build these distributed systems that were decoupled from one another via level 3 Richardson REST. Now I'm going to shout at the cloud again. I genuinely don't know what happened to a bunch of these technologies that were around at the time. Like microformats, for example, were a big thing. Describing an address as an address, everyone knew what the address was, what the format was. A calendar entry, all these things. You know, we didn't have to make. We weren't making our own stuff up every single time by every team. We were using these microformats. Where did domain application protocols go? The idea that what we're going to do is describe for the organization how we're generally going to communicate with one another, agree on it, and then we don't need to think about it anymore, right? But they don't seem to have been picked up either, really. And then who can I blame for JSON? No, I mean, really, who can I... Because it's the worst. It's the worst. It's just the worst. I know XML is verbose and blah, 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 but it does the job. It allows you to do things like include controls, hypermedia controls. You can have like schemas that you don't need to tunnel via weird mechanisms. Yeah, if I could find out, I'd give them a piece of my mind. Anyway, moving on a bit. There's a bunch of other things that have happened since, of course, because one of the questions we had building this resource-oriented thing using RESTful web integration techniques, it was essentially a message-driven application, event-driven application. And they said, couldn't you just use RabbitMQ? These days, I guess you could say, well, couldn't you just use Kafka? And Kafka is everywhere and fine. It's a wonderful piece of technology. It's like a reverse Polish database. It's got its transaction log line on the outside. A bit weird. And at the time, we were sort of talking about messaging. The thing is, right, messaging, I know everyone's doing it now, which is cool. Everyone's building event-driven systems. At the time, it was really, really hard. Right? People weren't used to thinking about eventual consistency and how events propagated and these sorts of things. I like this from Gregor. He talks about the architect's view. Yeah, you know, we can use messaging, and then we get loosely coupled systems, asynchronous, composable, scalable, real-time, and then you go to a developer, and they're like, well, how do I work out if stuff's broken? Or how do I debug this stuff? Like, how do I know when things are happening? This is like this is a nightmare. And that's still true, I think, today, probably. But we've just got, I think, maybe a bit more used to the ideas. This is a real quote from a project I was on when we were talking about event-driven applications, event-driven architectures and messaging. And I was working on it with Sam Newman, building microservices, Sam. And one of the client architects said, when you or Sam are in the room, we can understand it. But as soon as you leave, I've no idea how this works. Right? Well, that's probably a failure on our part to explain this properly. But this is pretty much the prevailing wisdom at the time. You built everything in one monolithic thing, and then you didn't have to worry about asynchronicity, etc., unless you're doing threading. So the other thing, couldn't you just use RabbitMQ? The other thing is gRPC, hugely popular now. Right, hugely popular for good reasons. Google needs something that has the properties of gRPC. Fantastic. I'll question whether many of the rest of us do. This comes back to another long-term presentation. Martin Fowler's law of remoting. Don't, essentially. But it's not quite remote. It's not quite object remoting. But essentially, it is. You're kind of calling a method over the wire, essentially. And we learned not to do that with SOAP-RPC. But hey, lost that battle as well. And now, of course, we're in the world of SQS. Everyone can use this. It's widely available. We can use lambdas to listen to notifications, or we can pick up messages from SQS, and we can do stuff with them using step functions and so on, which is great, because you've got this power to integrate all of our functions, our systems together with these cool new tools. But unfortunately, with great integration power comes a high probability of messing it all up. And again, we were shouting at the clouds at Thoughtworks here saying, this is quite hard, right? You can fall into this trap we call lambda pinball, where you suddenly end up with hundreds and thousands of lambda functions, of lambdas everywhere. And you don't really know what they're doing, how they relate to one another. It's a big spaghetti mess. And so something, you might get an API endpoint called, and suddenly there's a propagation of something and something's being called over here. Yeah. So our advice was to do things like make sure you're following domain-driven design, split these things up into different repos. Don't just have this huge mess of lambdas. Evolutionary design is the next thing, the next characteristic. And we were talking about replaceability a lot there. Now, the way I think of evolutionary design now is represented in this choose-your-own-adventure book I wrote for a talk some time ago called The Endlessly Bifurcating Trousers of Reality. And I don't know if that translates into Danish. But the idea here is essentially, the way I think that's very much related to Kent Beck talking about options and optionality earlier. Every line of code you write is essentially creating options. Right, or collapsing options. Every line of code you write is evolving the system in a particular direction. Every line of code. So how do you write code in a way that allows us to create options, to leave as many options open? This is something called an evolutionary graph. And this is like reductive ad absurdum, but on the one hand, you have choices. Do we build a distributed system, or do we build a monolithic system? And as you follow those choices through, you end up with, on the one hand, distributed system, on the other hand, a monolith. Essentially, as you progress with your design, you're collapsing these options. This is the idea of emergent design, or evolutionary architecture. Of course, this has been a lot of work done in history on this. I like this quote because he's a Danish philosopher. It's perfectly true as philosophers say that life must be understood backwards, but the problem is we live life forwards, right? We can't predict the future. So one way of guarding against that is by having optionality, creating options, allowing us to move in unexpected ways and take advantage of things like changing market conditions and volatility. As I say, lots of work being done. Martin Fowler, again, quote from him, or maybe it's Ralph Johnson, he couldn't remember. Software architecture is those decisions which are both important and hard to change later. The interesting thing about that is some of these decisions that we used to be hard to change are now easier to change. Things like, not the immediate design decisions, but things like where do we deploy our software? What network topology do we use? Are we going to deploy into an EC2 instance? Are we going to deploy via Docker into Kubernetes? That stuff is now lines of code. That's really easy to change. And building evolutionary architecture is going to do in a lot more detail about this. So instead of evolutionary design, I'm now talking about evolutionary architecture. I've not talked in this bit about a whole bunch of other stuff. Architecture, decision records, real options really, principles, constraints, how this ties into platform evolution, etc. Next thing, infrastructure automation. We missed a trick here because we were right at the forefront, it was right at the sort of beginning of the advent of infrastructure as code. We were using things like Chef and Puppet and so on, right? We came up with this idea on the radar of Phoenix servers or Phoenix environments. These are entire environments you can spin up via infrastructure code and to run your tests on and then collapse again. That was back in 2015. And we were writing DSLs around this, things that look a bit like Ansible and Terraform now. This was sort of happening back then. This infrastructure automation, provisioning things automatically. I mean, who'd have thought AWS would have been a thing? We didn't even really talk about the cloud when we talked about microservices originally. AWS became a thing, definitely. This is one of the original slides from the 2011 training course on AWS that I used to run, because Thoughtworks ran training for AWS. There's a lot more stuff going on these days. Never mind the cloud native foundation, right? This is the sort of current landscape of all the stuff that's been accepted into the cloud, into CNCF. It's pretty extraordinary. This explosion of tooling, explosion of automation tools and so on, that's happened over the years. And I love XKCD for the win. What do you do? I make tools that monitor code, that deploys tools, that makes tools, that builds tools for deploying monitors of tools, et cetera, et cetera. And there is a bit of that going on. Also, with infrastructure automation, continuous delivery was, only had been out a couple of years at this point. right, when this was published. So all the patterns around things like blue-green deploys, canary releasing, build pipelines, we were using them a lot internally, but I don't think they were that adopted by much of the wider industry yet. This is an example of a blue-green deploy on a set of services. So starting to adopt these new techniques, blue-green deploys, infrastructure automation. Now, where are we? Well, we've got infrastructure as code, or infrastructure as data, we don't really know, or infrastructure from data, that's also a thing, apparently. It's a bit of a mess, infrastructure automation, right? But there's some interesting stuff happening. This is on this side. It's on this side for you. It's the first window is System Initiative, which is the guy I think from Chef or Puppet, Chef or Puppet, Shuppet. One of those, who's got this really cool new, it's just gone into, I think, 1.0, new ideas about how you deploy your infrastructure and describe your infrastructure. And this is Winglang, which is another new approach that isn't just writing Terraform, that isn't or using Pulumi or CDK. So there's stuff happening, but it hasn't settled down yet, which I find kind of, it's an unsolved problem. If someone could solve it for us, that would be really handy, and I'm hoping something like this does. The zombie apocalypse, this is a cautionary tale from one of our clients where they were they had everything was in Amazon, in AWS, everything, including their build servers, everything. And they had this thing at the time where they'd run through at night, terminating what they call zombie servers. So if someone had forgotten to shut something down, they'd go through and terminate it. And they came in one morning and they'd lost 10% of their estate overnight. And they're like, oh, what's happened here? Like 10% of their infrastructure had just gone away. They thought, okay, well, they started everything up. Came in the next morning, rather, and they'd lost 90% of all of their infrastructure, including their version control, including their build servers. Pretty much everything had died. And it turned out they found a bug in BOTO, the Ruby library that talked to AWS. And that bug essentially meant the bug essentially meant that they terminated 90% of their instances. So, guardrails again, your mileage may vary. Design for failure. This is, I think, my final point. Again, back to Martin's law of remoting. Don't. The reason that remoting is hard is because there's a network in the way, right? In the great book, Release It, Michael Nygaard talks about every socket, process pipe, or remote procedure call can and will hang, even database calls. The art of Unix programming, I like this idea. And this is one of the things when you're building these small processes, I think this might have gone out of fashion as well, but the rule of repair what you can, but when you fail loudly and noisily and as soon as possible. I don't think we do that much these days. Of course, we had things like Chaos Monkey. The Simian army turned up. Use of GenAI in my talk. Hope you'll appreciate that. Thank you. And now we've got, this is just the observability bit of the CNCF, the bottom bit here. This is an entire industry that's grown since 2014. None of this was there. Docker wasn't there, and Kubernetes wasn't there, but none of this was there in 2014. It's amazing. Again, make tools that make tools that make tools that make tools that make tools. There's some interesting stuff happening in this space. I saw a brilliant talk by Charity Majors about Observability 2.0. I'm not sure if it's the title will catch on, but where she talks about the need to do different stuff with observability these days because we're spending a lot of money on logs and things. So instead of doing what we do, use things called canonical logs, wide logs instead. So I'd recommend going and having a look at her stuff on Observability 2.0 online. I'm going to finish up with a couple of things about unexpected side effects and things I might have done differently or thought about differently. Martin originally said that microservices move the accidental complexity to the infrastructure. Well, one unexpected side effect, apart from 50 million observability tools, is what happens to a lot of the stuff that we used to have to do per application or per service. So, AWS used to talk about, we'll take care of the undifferentiated heavy lifting for you. And essentially what's happening now is we've got a bunch of tooling that does that for us, except it takes care of the undifferentiated essential complexity. Things like service meshes take away a lot of the responsibilities that our applications used to have around things like authentication, blah, blah, blah. Things like Docker, things like Kubernetes. Right? The undifferentiated essential complexity of our applications. I say essential complexity as opposed to accidental, because it is essential, right? You do need to do things like do TLS, termination and so on. So it is essential. Again, developer experience platforms are probably the ultimate expression. This is Backstage by Spotify, or the marketing material for it. Backstage by Spotify. This is the ultimate expression of tools over rules. Right? How can we provide these interesting tools that allow you to get your stuff done effectively, right? But within guardrails provided by the developer experience platforms. And then you've got data mesh, which is the missing bit, data. We didn't talk about data, apart from this idea of using lots of databases and distributed transactions. So data mesh is the next sort of generation on, I think, how you apply the microservice ideas to data. What do I wish we'd done differently? I'm finishing up very soon. So any sufficiently complicated C or Fortran program contains an ad hoc, informally specified, bug-ridden, slow implementation of half of common Lisp. That's Greenspun's 10th rule. I refer you now to Daniel Terhills North's rule, which is any sufficiently complicated microservices implementation contains an ad hoc, informally specified, bug-ridden, slow implementation of half of Erlang. So maybe you can have a look at Erlang. That would be one tip. I'm going to yell at the cloud a little bit more. Infrastructure as code is still a mess. We need to fix that. We've still got single integration testing environments on hold on our Thoughtworks radar. We're still doing that. We're still having one thing that we have to deploy everything into. We're not deploying independently a lot. The name, I think it's a stupid name. Unfortunately, when Martin names something, it stays named, right? You can't get the option afterwards. So it's microservices. We missed out. What did we miss out? Well, we missed out on mentioning the cloud. We didn't talk about the cloud at all. We didn't really talk about CD, continuous delivery, as a first-class concern. We talked about it in passing. And we didn't talk enough about independent deployability. I mean, we didn't talk enough about, can I just say, we didn't talk enough about independent deployability. So if you take anything away from this, please make these things independently deployable. So, at the end of the article that Martin and I wrote, we asked this question, are microservices the future? We write this with cautious optimism, we said. We've seen enough to feel it's a worthwhile road to tread. And then in the 2023 State of DevOps report, they have this idea of loosely coupled architectures, which includes the microservices style of architectures, leading to substantial increases in team performance, organizational performance, and operational performance. So I don't know if they're the future, but they're certainly not doing terribly at the moment, doomsayers aside. The future, what does the future hold? Robots powered by microservices, that's it. Thanks very much.